Before we start, I want to clarify something. I used the word implement a lot in this video, so I want to define it really quickly. All implement means is that to write the code for something. There's a bunch of ways we could implement the same thing. You could argue that one is faster than the other, one is this than the other, but at the end of the day, even though the code is different, they're both doing the same thing. So again, all implement means is to write the code for. Okay, good. See ya. I want you to think of an interface as a contract. In this contract, there are methods that any class that agrees to implement the interface needs to fulfill. More on what that means in a second. Essentially, when a class says, hey, I'm going to fulfill this interface, it's under contract to fulfill all of the methods in the interface. We'll talk about how to write that out in code in a second, but to begin with, let's talk about in what situations an interface might be useful to us. Let's say I'm a light bulb company. I want to make a new line of light bulbs. One of the light bulbs senses when a group of people are in need of a party and turns to a disco light bulb. Another one of the light bulbs mimics the sun, while another one uses AI to automatically dim itself, and so on. Now, I am a light bulb company, not a software company. I don't know how to make my light bulbs do this. So I decide to collaborate with Microsoft, Google, and Facebook. Sorry, I mean Meta. And assign them each different light bulbs to work on. Each company will probably get the job done. However, what will differ is how they choose to code or implement each light bulb. So each company is done building now, but now I have a bunch of light bulbs that work, but all of them work differently. For example, for one light bulb, you have to shake it to turn it on. For another one, you have to touch it. For another one, you have to twist it. So technically, all of the light bulbs work and do what I want them to do, but now my customers are really confused because each light bulb works differently. And they have to learn how to use each light bulb every time they buy a new one. How could I have prevented this situation? Want to guess? That's right, interfaces. Good job. Genius you. Remember, an interface is just a list of methods that we're going to require classes to implement. So in my interface, I could have a method called turn on, which requires the user to touch the light bulb to turn it on. I could have another method called turn off, which requires that the user should clap to turn off the light bulb, and so on. Each company can code up this interface however they want. But at the end of the day, for each light bulb, my user would know to touch it to turn it on and to clap to turn it off. Why was this possible? Well, it was possible because we had a user interaction interface, or an interface specifically for user interaction. And each company had to fulfill that interface. Each company may have chosen to fulfill it differently. The specific implementation details may be different. The specific ways they wrote the code may be different. But at the end of the day, you touch it to turn it on and you clap to turn it off. As a side note, I want to point out that a class can implement as many interfaces as it wants or needs to. That will hopefully make more sense in a few minutes. Concept summary. Let's summarize what we've talked about so far before we move on. An interface is a contract. By saying that a class is going to fulfill an interface, the class is promising to provide the implementation details for the methods in the interface. Moving on, here's how we code it. Well, actually, one more thing. First of all, it'll probably be helpful to you to realize that you cannot instantiate an interface. This is because even though an interface is a reference type, All it's really doing is just defining a list of methods that something else has to implement, that another type has to implement. If that doesn't make sense to you, don't worry about it. Just remember, I should not instantiate an interface, and then just don't instantiate it. Now that that's out of the way, let's write some code. Okay, so I'm gonna use an online Java compiler to show you guys how to do this interface, just because people might be using different editors, and this will just make it easier for all of us. Let's jump into it. Declaring an interface is very similar to declaring a class. So when we're declaring a class, we'll go like public class followed by the class name, right? Well, to declare an interface, instead of using the class keyword, we're going to use the interface keyword. And then we can write out our interface name. So in this case, we're going to be making an interface for turning on and off the light bulbs. So we're going to call it on-off controls. Perfect. I do quickly want to remind you that if you're writing in an editor like Visual Studio Code, you're going to want to make sure that the name of your file is the same as the name of your interface. Also, you need to remember to use the .java extension. Now I'm going to go ahead and write the methods that I'm going to require that these companies fulfill. So public void, I'm using void because I don't expect them to be returning anything. So void, there's a turn off method. Perfect. And then we have a turn on method. Notice that I don't provide any implementation for these methods here. I don't have any code, like I didn't do this and then start writing some code. These are called abstract methods, and abstract methods are simply methods that do not have implementation. Let us continue. So let's say I also want them to make sure they have a function where the light will automatically turn on and one where the light will automatically turn off. Perfect. That is my interface. Now that my interface is complete, how would a company use this? How would a company use this interface to create their own classes? Well, let's pretend we are Google. I'm just gonna go down here and we are Google. Okay, so let's say Google, an engineer at Google is writing a class, so public class. In this class, they're developing our disco light bulb. So disco light bulb. Now, to make it clear that we are going to be fulfilling this interface, we use the keyword implements, and then we say the name of the interface. So implements on off controls. So to summarize what's happened here, we declare our class like normal, public class, then the name of our class, and then we say implements the name of our interface. So I've now agreed to fulfill the requirements of the on-off controls interface. So I want to write the methods that are required by this interface. So at this point, by saying we're going to implement the on-off controls interface, we've agreed to fulfill it. So we have to do that. So I'm just going to go ahead, public void turn off. And unlike where I could just leave it as an abstract method in my interface, now I actually need to give it some implementation. For this video, we don't actually care about how to implement that. So we're just gonna code that out, leave that out. Public void turn on. And it needs to be exact. The name needs to be exact, of course. Implementation. Cool. So we've done that, but we're missing one thing. And that is the override tag. So the override tag is an example of something called an annotation tag. Annotation tags have a bunch of different uses, but one of their uses is talking to the compiler. So in this case, the override tag, what the override tag does is tell the compiler, hey, I'm providing the implementation for a method that was in the interface. So for every method that you write that was required by the interface, you need an override tag. So unless the interface provides the implementation for a specific method already, then you're going to need the override tag when you are providing the implementation. Let's summarize that. If you are providing implementation for a method that was required by the interface, you need the override tag. So let's continue. I have to fulfill all of my contractual obligations to the on-off controls interface. So I need to finish implementing the rest of the methods. By the way, I hope you are typing along, coding along. It helps you learn a lot better. Great. Now that I'm done writing all of the methods, all of the implementations for the methods required by the on-off controls, I can go ahead and start writing my own methods for the disco light bulb. So I am a Google engineer. What does my disco light bulb need to do? Well, I know that the customer wants this light bulb to detect sadness and turn on a disco party when people are sad. So I'm gonna write a detect sadness method. And here's the implementation for it. And notice, I'm not gonna use the override tag here because it's not required by the interface. This is not a method that was required by the interface. Okay, continue, and blah, blah, blah. I'm gonna keep writing because I'm an engineer and that's what we do. Yeah, I want my light bulb to play disco music. So blah, 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 implementation. And of course I can keep on going. All that matters here is that I have fulfilled my contractual obligations to the interface. Okay, so that was a lot. So let's just take a step back and summarize things. First, declaring an interface is like declaring a class, but we use the interface keyword instead of the class keyword. Second, interfaces can have static methods, default methods, and abstract methods. Third, so far we've only talked about abstract methods. Abstract methods are just methods that are declared without an implementation. Fourth, to tell the compiler that we are entering into a contract with a given interface, we say class, the class name, implements the interface name. Last but not least, we use the override annotation to tell the compiler that we are providing the implementation for a method from the interface. Cool. Now you understand what an interface is and how to implement one. In the next video, we're going to talk a little bit more about interfaces. We're going to talk about how to extend interfaces. We're going to talk about how to implement multiple interfaces. And then we're going to talk about default methods and static methods. Thanks for watching. See you later. That was cringe. I regret saying goodbye that way, but I'm not refilming, so I apologize.